Welcome, ladies and gentlemen. This is video number 1 in our atomic structure unit. So again, make sure you got your note packet open to where it says video number 1. In this video, I'm going to be quickly summing up the ideas of the atomic models that we've seen so far, and then introducing 2 new atomic models, and just going over those. So our goal with this video is to be able to describe the different atomic models in terms of their timeline and who came up with what idea. Names aren't so important as are the ideas that actually went into the models. So first up, Dalton, Thomson, and Rutherford, what we did with the atomic structure project. These are the 3 that we looked at, and they are sort of going in order in terms of who developed what first. Dalton, if I were to draw a model for Dalton, what Dalton thought the atom looked like, remember he was the first one who really scientifically came up with the idea of the atom and produced data and evidence that everything was made of atoms. But he thought atoms were hard spheres. So I always kind of picture like a marble or a bowling ball, in that it's just this hard sphere, it's indivisible, there's nothing smaller than the atom. The atom is as small as it gets, which is not true. We know that now, right? We have things called protons and neutrons and electrons, and even like protons and neutrons are made up of other things. So this is Dalton's model of the atom. It's just one thing, like a marble. And then we have Thomson. And his was the plum pudding idea, or if we think of that more recently, like a chocolate chip cookie. Thomson discovered the electron, but he didn't know about protons or neutrons. So he kind of thought that the atom was this big sort of center, had this positive, almost goo, that would be like the cookie portion of chocolate chip cookie dough, that was positively charged, but that he also figured out that there were electrons, so embedded within the cookie dough are electrons, negatively charged particles. He didn't actually call them electrons, he called them something else. We renamed them electrons later on. But now we have evidence for the existence of smaller things within an atom. So that's the big idea that we moved forward from Dalton to Thomson. And then Rutherford, and we will be going over Rutherford a little more in class because Rutherford did some really amazing stuff. Rutherford figured out that an atom has a nucleus. That's what he came up with. So he figured out that in the center of the atom, we have a small, positive, dense nucleus. He knew it was small, he knew it was positive, he knew it was in the middle of an atom, and that everything else in the atom, right, all this other stuff here, was just empty space. Lots and lots and lots of empty space in an atom. So now we basically have, hey, there's something small and positive in the middle, and this negative stuff that Thomson was coming up with, it must be on the outside, so I'll even add that in. The electrons, like, they got to be on the outside, and there's a lot of empty space within the atom. So that's what we covered with the Atomic History Project. But there are 2 more developments in the atom that I'm going to cover right now. So first up is Bohr. Bohr followed Rutherford. He came after Rutherford, and he really is considered sort of the father of quantum mechanics. And Bohr pushed the model of the atom forward by really looking at electrons. So he was like, okay, that's great. Rutherford, cool. Yeah, we got a nucleus. All right, let's look at how the electrons are actually organized within an atom. And Bohr worked out that the electrons weren't just kind of a mishmash all over the place, but that they actually had these fixed, stable, what he called what we can think of as orbits, which are more frequently called energy levels or energy shells that had to be at fixed distances from the nucleus. So electron levels, electron shells, that the electrons just couldn't be any old place in the atom. They had to be in sort of specific locations or shells, and that there were lots of shells within an atom. There wasn't just 1 electron shell or 2 electron shells. There could be more than that. Each one of them had their own distance from the nucleus, and each one of them had their own energy. And he also worked out that the closer the shell was to the nucleus, the lower energy the shell was. Basically, being closer to the nucleus actually helped to stabilize the electron and give it a lower energy. And the farther from the nucleus the shell was, the higher energy the electron shell had. And this is a massive idea, so I'm going to all kinds of make sure it's important that we get this idea. That the closer the shell is to the nucleus, the lower energy it is. The farther the shell is away, the more energy the electron will have if it's in that shell. But, the sketching it, what would this look like if we're trying to draw this like we drew the other ones? Think of kind of an onion. That's basically what Bohr's model had. So we've got now, just like Rutherford, we're going to have our nucleus in the middle, small and positive, but now we have electron shell. This would be shell 1. The one that's closest to the nucleus, shell 2, then shell 3, and shell 4. And the electrons cannot exist in between shells. They have to exist at a certain shell. And shell 1 would be lowest energy, and shell 4 would be highest energy. Which this idea of Bohr's really pushed the model of the atom forward quite a lot. But the thing was, he was wrong about some stuff. So pushing it forward even more, we have what is our currently accepted model of the atom, meaning we have yet to have any evidence that disproves this particular model of the atom. This is called the quantum mechanical model. And that's how I will very typically refer to it as. It was developed by Heisenberg and Schrödinger and a lot of other people as well. And it's the modern model. It's what is currently accepted today. And it keeps intact a number of ideas from Bohr's model. It still talks about electron shells, and we're going to look at that in detail at the end of this unit. But the really big identifying portion of the quantum mechanical model is it threw out Bohr's idea that you could know absolutely within a shell where an electron was, and instead introduces this idea of orbitals. And this is a super big vocab word for us. I'm going to really be pushing that, especially when we get to the electron stuff later on. An orbital is a region of space where you are highly likely to find an electron in an atom. Notice there is no certainty in that statement. It's probability. It's, hey, I'm likely to find an electron, and you don't know for sure if it's there, but you have, a reasonable idea that it's there. So we have now this introduction of the idea that we cannot know for certain where an electron is. I kind of describe orbitals like, the analogy would be like your parents knowing where you are when you're at school. Meaning your parents have a reasonably high probability of knowing that you must be somewhere within the Webster Schrader building, right? They should be like 99% certain that you are actually in the building. But the thing is, they can't be 100% certain that you're within the building. Maybe you're at gym. Maybe you're going outside for gym. Maybe you're cutting classes. They don't know, but they should be like 99% certain that you are in the building somewhere. But they don't know exactly where you are in the building, right? They can't pinpoint your exact location. And if they can, I'm sorry, because that's slightly crazy, but like they don't know exactly where you are. They know that you're in there somewhere, but they don't know exactly where you are. So impossible to know exact location of electrons. That's really the same idea with orbitals and electrons. And we often hear orbitals sometimes referred to as electron clouds. So if we want to sketch the model, we've kind of got these fuzzy regions of probability where the electrons are within the atom. And that's if you think of like a fan, what a fan looks like, a circular fan when it's going, where you can't actually see the blades, they're just all fuzzy and blurry. That's how you would try to sketch an orbital, right? A fuzziness, blurriness. And we know that the electron's in there somewhere, but we don't know exactly where.